So if you're just entering the room, we're just putting in the chat our names and then a freshwater buddy that is special to us. And then we're going to get started. So again, thank you everyone so much for joining today's Freshwater Stewardship Community webinar. We're very grateful to have Meghan with us from the Gordon Foundation, and she's going to be talking about DataStream today. My name is Monica, and I'm the Communications and Fundraising Manager at Watersheds Canada. And so I'm going to be your host for today's webinar. If you have any questions about things that you're hearing or about any of the programs you hear, and also if you're having any problem with technology, you can reach out to Nicole, who is also with Watersheds Canada. She's going to be in the chat dropping some links and sharing some resources. And so Nicole and I are here to help you. And if you are unfamiliar with Watersheds Canada, we are a national registered charity. We're headquartered in Eastern Ontario, and we work with communities across the country to deliver different freshwater stewardship and education programs. I have a couple pictured on the screen here, including our fish habitat restoration program on the left, where we are washing a spawning bed for fish and restoring it before the spawning season takes place. We also do shoreline planting projects, which you can see in the top right. And so this is a larger site that's in the photo, what we call a demonstration site at something like a public boat launch or a public park, and involving different community groups to help restore the shoreline habitat there. And then we also deliver children and youth programming, which you can see in the bottom right, a recent workshop that we did in a March break camp where we introduce the participants to different local species and also freshwater issues and help them get involved in taking local action. One thing that I wanted to share about Watersheds Canada, sort of a neat way that you can support the freshwater protection work that we deliver, is through our symbolic adoptions program. So we offer different adoptions for different freshwater species and shoreline species. And what you receive is a 5x7 postcard featuring artwork made by Canadian artists. We have a couple examples on the screen here. All symbolic adoptions also come with a Canadian charitable tax receipt. So it's a really special way to give a gift or just get a really nice piece of artwork that you can frame and put up on the wall or have at your desk. You also get a blank card with all of these adoptions. So if you do choose to give it as a gift, you can personalize it for the adoption and the recipient. So if you would like to learn more about our symbolic adoption program, you can go to watersheds.ca/gifts. The program that we're here for today is called the Freshwater Stewardship Community. It's a bit crazy to believe that the program has been running since 2021. We have a really great back catalog of all the recordings and handouts from over 50 webinars. And so the page that you went to register for today's webinar, you scroll down on that page, there's a couple of different boxes of topics and everything is grouped by topic for you. So you can access all of those resources for free. And again, the website for that is watersheds.ca/freshwater-stewardship. Want to thank the Hodgson Family Foundation for the funding that they provided for our 2026 webinar series, and also for the creation of the handout, which you will get next week along with the recording from today's session. Online programs sometimes feel like you're just a person on your own listening about a topic and trying to make a difference in the world, but our freshwater stewardship community is a global community. It's representing over 15,000 people in 30 countries. And so it's a really lovely way to work together with others across the country who are also caring about freshwater areas and trying to make a positive difference. Another place where you can access a number of free resources is our e-library. So this has our webinar recordings, like I mentioned, but also a host of other guides, resources, blogs, handouts, activities for families. So you can access all of those for free. You can download them, share them with your community group, your family, educators, wherever you think someone might be able to use them. And you can access all of those for free at library.watersheds.ca. If you are a social media inclined person, you can connect with us on any of these 6 platforms. And if you have any questions after today's session about anything that I just said, or you're interested in learning more, you can reach out to me at info@watersheds.ca. With that, I'm going to introduce our speaker for today. So Megan works for DataStream Initiative as a data specialist. DataStream is an open access platform for sharing water quality data across Canada. As a data specialist, Megan works across sectors to provide support to monitoring groups that want to format and publish their data on the platform. She also supports users in finding the data that they need and helps to facilitate integrations between other systems and DataStream. Megan holds a Bachelor of Mathematics and a Master's in Science from the University of Waterloo, where she studied nutrient contamination modeling in the Lake Erie basin. With that, I will welcome Megan.
Awesome, thank you. Let me share my screen. Can I replace the current share, I think?
Yes, go ahead.
Okay, great. Okay, hopefully you should see some slides. Okay, hi everyone. Yeah, my name is Megan. Thanks for the introduction, Monica. And for the next hour, I'm hoping to talk with you a little bit about data and specifically bringing Great Lakes freshwater data together. I'm based in Toronto and I live, just because of the prompt Monica gave, I live a few minutes away from Lake Ontario. So that would be the water body that I would choose. So to start, for those of you that are unfamiliar, I thought I could give a brief introduction to DataStream and what we do. So DataStream Initiative, as was mentioned, it's a registered Canadian charity dedicated to advancing freshwater protection. And ultimately, our mission is to promote knowledge sharing and collaboration so our waters can remain healthy for generations to come. And we do this by providing a free open access data sharing portal. And this portal provides a neutral place to store, share, and compare Western scientific water quality data. And this should reduce barriers to access data by providing a central, neutral location for many monitoring programs and projects to share data in a standard format in one place. So a note on our history in terms of where things started. DataStream was originally developed by the Gordon Foundation, which is a long-standing Canadian charitable organization whose work involves water protection. And DataStream started in the Mackenzie Basin, which you can see here, where a lack of access to freshwater data was identified as a major barrier to freshwater protection. So in 2016, the foundation teamed up with the government of the Northwest Territories to build a publicly accessible hub to house the results from various monitoring programs, community monitoring initiatives in the region. And so that's how Mackenzie DataStream was born. And once Mackenzie was launched, it was clear that there was a similar need in other regions across the country. So today, since 2016, DataStream has grown quite a lot in the last 10 years. It's now its own registered charity and hosts data across the country and is active through 5 regional data hubs across Canada. So you can see there, Mackenzie, Atlantic, Great Lakes, Lake Winnipeg, and Pacific DataStream are all our regional hubs today. And we've expanded into these hubs through more regional partnerships. So in addition to the government of the Northwest Territories, you can see listed Atlantic Water Network and Lake Winnipeg Foundation are also our regional partners today. And in terms of our growth, you can see that there's quite a lot of monitoring groups that are contributing across the country, with today 357 groups contributing lots and lots of data. And just before I continue, though, it's really important to note that those who are sharing this data are those who maintain ownership of the data and control what they choose to publish. And so DataStream does not fund, own, or collect any of this data, and we don't upload the data ourselves either. And so to zoom into Great Lakes DataStream, this is one of our hubs, as you saw. It's newer than Mackenzie. It was established in 2021, so it was about 5 years ago. And in this presentation, I'll use the Great Lakes Hub as a bit of our focus. And my work as a data specialist is focused in this region specifically. And so as you can see with some of these stats, there's a lot of monitoring happening in the region with over 90 different contributing groups. And we have data from many group types, but community-based monitoring organizations make up about half of the contributing groups in the region. And this is a theme that you'll see across all of DataStream, including the Great Lakes Hub. So just kind of at a glance to help you understand how our system works, If you're a contributor or a data collection organization and you're collecting water quality data, you can either directly upload that to DataStream through a free account, or if you already have your own open data portal where you store and share data publicly, you can also set up an automated integration with our system so that ultimately, either way, your data is available on DataStream so that you can access it, but it's also free and available to anyone else to access it. And then that data can be downloaded, it can be discovered, it could be connected via API to other systems, and then ultimately it can be used. And so here are just some examples of organizations who are maintaining their own portals who we've worked with on integrations to DataStream. And so you can see just in this short list, there's a lot of different organization types here. You see a lot of provincial governments, some municipalities, some community groups, each with their own portal structures, their own schema. And we work with those groups to make connections so that our systems can talk to each other, so that data can be translated between the two. And the important thing is on DataStream, we always like to point back to the source portal so it's clear that this data set is integrated from somewhere else. And just to highlight one of these integrations, Water Rangers is one of our close partners, and they have their own platform where Water Rangers test kit users can upload data on their own site. And groups then who choose to opt in can have their water quality data ported from Water Rangers to DataStream. And so both systems point to each other. So Water Rangers points to DataStream and we point to them. And then data is leveraged in two places. And I mentioned this specifically when talking about the Great Lakes, because a huge fraction of those Great Lakes DataStream community-based monitoring groups that I mentioned before, they come from Water Rangers. So there's a really good chance if you're exploring a community-based monitoring organization in the region, they're going to be a part of this kind of Water Rangers DataStream ecosystem. Okay, so I've mentioned all these groups collecting water quality data and that we're a water quality data platform, but what is that exactly? So water quality data includes all kinds of things. It includes laboratory analyzed data, so things like nutrients and metals and PFAS and kind of these chemical concentrations that you need a laboratory to analyze exactly what's floating in the water. There's also field data, so in situ measurements like pH, temperature, depth, these more physical parameters that describe the water body. And in the context of DataStream, when we accept water quality data, we're accepting surface water and sediment data, but we're very excited to be developing a groundwater component to our portal, which will be coming soon in the next year, hopefully. And again, in the context of DataStream, we're talking about natural or ambient water samples. So that wouldn't be the water quality of data coming from your sink, for example, or water quality that's leaving like a water treatment plant, for example. And water quality data can help us to understand all kinds of things, stresses on aquatic life, pollution sources, groundwater contamination, drinking water safety are just a few ways that are reasons why folks might be interested in collecting this kind of data. That said, though, DataStream is just one piece of the puzzle when it comes to knowledge and data systems. There are many other kinds of data out there that help us describe a watershed. You have species count data, water quantity data, qualitative observations, traditional ecological knowledge, climate data, land cover maps. All of this data needs to come together to tell a full story about a watershed that you're looking at. And so we recognize that, we are just kind of one piece of this large data system. And I'd recommend if you're interested in learning a little bit more about water quality or you want to dive into a specific water quality parameter or at least a water quality group, you should check out our water quality guidebook, which is free on our website. And this basically just at a very high level describes what water quality is. You can see there's biological, physical parameters, nutrients, and you can just dive a little bit into what they are, why they matter, and how they're measured. Okay, so there are lots of groups that are monitoring this data, as you saw. They're monitoring to learn about their environment, to answer questions, to inform policy. And on our portal, we receive data from all kinds of groups. You have governments contributing data, so that could be like provincial governments or the federal government even. You have watershed groups, so in the Great Lakes, that would be our conservation authorities. Community monitoring initiatives, as I mentioned, including Indigenous organizations, as well as academics. And I just zoomed into a river near where I live. This is the Humber River leading into Lake Ontario, right by me in Toronto. And just in the stretch alone, you can see there are at least 5 different groups, all very different, who are collecting water quality data. So you can see there's a conservation authority on the list. There's the Government of Ontario. There's some community-based monitoring initiatives. The Lake Partner Program is a combination of volunteers, but it's led by the government. So just in this small little area, you can see that there are so many different kinds of groups that are collecting data. And our blog series is something that we use to highlight the various contributors of all these different kinds. So they tell stories about monitoring programs and lessons learned and all these different kind of motivations towards collecting water quality data. And so I thought, to give you some perspective, we could dive into some specific examples of monitoring motivations. So I pulled some Great Lakes DataStream stories that we've showcased before. So the first is the Madawaska Canoe Center, which is a kayaking and canoeing school. And using Water Rangers test kits, the office team collected monthly water quality samples. And by tracking water quality, this not only informed the group about things like temperature fluctuations, but it also deepened their relationship with the water. So that's a great motivation of education and connection. Ottawa Riverkeeper is a great example. The city of Ottawa wasn't tracking chloride data during winter months, so Ottawa Riverkeeper stepped in, launching their own community-based monitoring program where they measured chloride after events like freezes and thaws and precipitation. And so they're able to evaluate impacts on water quality. And then Garden River First Nation ran a pilot program to monitor their local waterway. And so by acquiring their own data, the community will know what the baselines are in order to understand how and why things change in the future. And so they'll have this baseline data as evidence moving forward. And so as you can see, there's lots of data being collected, but very differently and for very different reasons. It's collected differently, it's formatted differently, it's stored differently, and it's motivated differently. Some monitoring programs are going to be really short, maybe just the season. Others are really long and span decades. Some are in response to an environmental event specifically. And different organizations, of course, have different capacities and access to different monitoring tools and different funding. So that's going to mean that their collection is going to look really different. And this is why data management really matters, because you have all of these groups that are doing their own monitoring in their own ways. So when it comes to managing the data that comes out of these programs and sharing that data, you really have to be careful and consider how that data can be found and how it can be ingested. So just as some motivation, this is the watershed reports put out by Water Rangers just last year, and they assessed the watershed health of watersheds across Canada. And one of the indicators that they looked at was water quality, and they pulled together data from all kinds of places, including DataStream. And it turns out that they couldn't assess about 76% of subwatersheds in Canada due to insufficient data. And so while it's true that some watersheds have very little monitoring happening, in some cases, data is being collected, but it's inaccessible or it's behind paywalls or it's hard to find. And so this data access challenge makes it harder to get a full picture of freshwater health when organizations like Water Rangers are trying to pull all this data together. And another challenge we've heard about is data ambiguity. So some data sets are available and they can be found, but they're missing key pieces of information that make it unusable. So this is a 2017 study looking just at this challenge. They look at challenges with secondary use of secondary source water quality data in the US. And secondary use data is basically the use of data beyond the original intent that was determined by the organization that collected it. And they found that in a study of 25 million data records from rivers, a huge portion of those had ambiguous metadata that limited their ability to use it. And so ambiguous metadata could be things like missing or unclear units, missing or unclear sample fractions or method speciations or location coordinates. And they estimated that this kind of equated to about billions of dollars that was lost because of these ambiguous records that were difficult to use or difficult to trust. And so at DataStream, that's a big part of our motivation, is to help and bring all of this data together and to help it be useful. And so part of this, how we do this is through our open data schema. And our open schema follows a standardized data format based on the WQX standard for the exchange of water quality, which was developed by the USGS and the US EPA. And when I say schema, I really just mean a set of guidelines and rules about how the data should be formatted and how all the data that's uploaded onto the platform must have the same fields, and each field must use the same vocabulary. And then it also ensures that the data sets have to have basic metadata requirements to ensure that data is usable. So for example, you couldn't upload data onto the system with missing dates, for example. And so when we're talking about metadata, there's kind of two levels that you can think of. You can think of dataset level metadata, and that's an overview of the entire data set. So that's where you're talking about the title of the data set, the abstract, maybe an email that you can contact if you have questions, a collection organization, maybe some collection protocols or QA/QC. And that idea is that you're handed a table and you might want to know, where did this data come from? Who collected it? How can I trust it? That's your data set level metadata. And then at the more granular level, you have observation level metadata, and that's details about each record in the data set. And that would be described by fields or column headers. So that's your classic date, time, value, unit, all of the things that you need to make sense of a water quality record. And here's just an example of why metadata is important. So here are just two aluminum measurements. They're the same value, so you might think that they're the same, but they have quite different metadata. One is measured at the surface, it has a depth of 0 meters. One is taken quite deep down in the water column. The other is, one is sent to a certain lab with a certain methodology. The other is going to a different lab with a different methodology. And this should be considered because different labs have things like different error bounds or different detection limits that they use. And then finally, they're reported in different sample fractions. So one is reporting dissolved aluminum and one is reporting total aluminum, dissolved being the bioavailable fraction of the metal, whereas the other includes what's bound to suspended particles. So just by looking at that metadata and considering that metadata, suddenly you've learned a lot more about these two samples and that they actually aren't exactly the same. And so our goal is to ensure that all the metadata fields are populated and that two data sets coming from completely different organizations can come together with enough metadata that's needed to compare them and to make sense of them. That said, we know that data is very messy, and this is the reality of a lot of the data that we're dealing with. It's often not clean. It can be challenging to pull together. And as a data specialist specifically, I've encountered a lot when it comes to raw data. And I'm sure that anyone here that's worked with data has seen some sites a bit like this before. Some examples are PDFs. So PDFs are not computer readable. Data can be buried deep in old reports. It can be hard to find. Sometimes it's hard to search for, and it's hard to tell what's data and what's just text around the data. Color codes, this can be really, really helpful to visualize data, but if colors represent anything really meaningful, sometimes interpreting those codes can be hard, especially when it's older data that's being reviewed, or especially if it's not your own data that you're looking at. And on top of that, most scripting systems or computer systems don't consider styling when they're ingesting in data. So sometimes these codes can be ignored and you can miss something important like a flag. Ambiguous short terms, often in primary data, because we know what they mean, we like to use short forms, but this can be confusing for secondary users. And even worse, it can be misinterpreted sometime and it can be assumed to be maybe something that it's not. Lab reports, for those of you that have ever sent anything to the lab, they can be quite tricky since labs use their own unique vocabulary and sometimes details can be quite technical. Duplicate data is another common challenge where often multiple spreadsheets might have the same record kind of spread amongst different places or people, and it was sent to a bunch of different groups. So that's a challenge as well. And then historical data sets, I think, are something that maybe we've all seen at one point. And data was collected decades ago, so formatting options were different. Reporting formats change over time. And so this is something that we also need to tackle when we're pulling together lots of different data. But luckily, to help with these formatting requirements, DataStream offers one-on-one support to data uploaders and data users through our data specialist team, which I'm a part of. And our job really is to support data uploaders. And we offer support related to uploading data, formatting data. We also have many resources online that we can walk you through and provide to you. And we definitely recognize that capacity can make it so that data processing and publishing can be time consuming. So we aim to provide capacity by meeting stewards where they are and help them along the way. And also we try to prepare them for future monitoring seasons kind of collaboratively so that that collection to data formatting to publishing is easier every time you do it because you sort of get a seamless process going moving on. Oops. And then the light at the end of the tunnel is ultimately all of that formatted data that folks work so hard to pull together and to format is then stored on DataStream and is publicly available. So now that we've kind of reviewed what water quality data is and how it's formatted, I thought I could walk you through the platform so that you can learn yourself how to go and look and find data and maybe zoom into your local waterway and see what's going on there. So I'm going to change my screen. Okay, hopefully you can see Great Lakes DataStream now. Okay, so when you come onto Great Lakes DataStream, there's a lot of different kind of drop downs here. You can look at other hubs, you can contact our team, can look at some of those resources I mentioned. But for today, I thought we could just go through quickly our Explore map. So if you want to explore data on Great Lakes DataStream, you can just click Explore Data here, and you're brought to a map. And this map contains points from all the different data sets across all of the hub. And as you zoom in, you can start to see you get more and more granular. You can see more and more sites. And eventually, you might find a site that you're interested in. So you can hover over a site and you can see what data set it belongs to. So this particular point belongs to Lake Pulse, which is a research-based data set. And then another way, though, that you can find data instead of just zooming in, around, and clicking is through this search tool in the top left here. So you can filter by several things, for example, by region or by watershed. And if you wanted to see those watersheds, we have a layers tab here that you can click on the watersheds and see kind of which watershed you're looking at. You can also filter by characteristic. So for example, maybe you're only interested in data sets that contain chloride. So that might be a filter that you want to use. But usually the most helpful one I find at the very beginning, if you're just poking around, is this organization dropdown. And this is a great way, at the very least, even just to look at all of these different contributors and all of these different people that are collecting water quality data. Before I started at DataStream, I definitely would have had no idea there is this many people collecting data. So once you've kind of poked around and found maybe an organization that you're interested in, say the District of Muskoka, you can click on an organization and you're brought to the region that they collect in and a list of all of their data sets. So in this case, they're only collecting one data set, so we can just go to that one. And when you click on the data set, you're brought to a visualizer page. And the visualizer is a way to look at the locations in the data set and the characteristics of that data set, and you can plot locations over time for each of these characteristics. So you can see all of the different characteristics here that you can toggle between, you can select whichever one you're interested in. One way to select a location is through the side panel, but in data sets like this, where you have a lot of lakes that are being sampled, I find that it's always easier to go to this map tool and select locations this way. Oftentimes, folks are interested in a specific area or region, so you can use the select tool to select a specific area of interest. Let's say that I'm interested in these 2 points here. I've selected them now, so if I go back, now only those sites are selected, and you can hover over them to see which lakes or which locations they are. You can change the chart type if you're interested to go from scatter to box, for example, if you want to compare locations that way. And then you might have noticed pH was up first. Some of the parameters have guidelines next to them. And what that means is that they have freshwater guidelines for the protection of aquatic life available. And you can read a little bit more about them up here. And these are provided by federal agencies like CCME and the US EPA. And if these are relevant to you or give you any sort of context about the data you're looking at, you can toggle these on or off. And then finally, in terms of this visualizer, when you're on a specific characteristic, if it's one of those characteristics in that Monitor's Guide to Water Quality that I showed you before, if you click this explainer tab, you get put right into the page about that parameter. So this is all about pH. It tells you what it is, why it matters, and how it's measured. And then you can also even see other parameters that you might be interested in related to pH. And then if I go back to the visualizer and I select a different parameter, say alkalinity, and now I go back to the explainer, now you can learn all about alkalinity. So hopefully that makes the data a little bit more accessible, especially if you're looking at data that you're not familiar with, that you don't really know what it means. And then finally, because I talked all about metadata, on the left here, this is tells you a little bit about the data set as a whole. So the abstract and how you're going to cite that data if you're going to use it in another way, collection information, any sort of disclaimers, things like that. And this is really, really important. I always recommend that you read this when you're looking at data to give you a bit of context behind the data set. And finally, you can download the data, or if you want to come back to that data, you can save this DOI. So this DOI link will always resolve back to this particular data set. And every data set on DataStream has its own unique DOI link. So even when the District of Muskoka adds more data or changes something in the metadata, it doesn't matter. This link will still always resolve back to this data set. Okay, so I'll stop there for my tutorial and I'll go back to my slides. Okay, hopefully we can see my slides now. So what you just saw was the Explore map, and that's a really great way that you can find and select data sets kind of across the whole hub. But I also mentioned there's DOI links. So if you already know the data set you want to look at, or it's your own data, you can kind of skip that Explore map and you can go right to the data set itself using that DOI link. So you can jump right to the visualizer or download the data. And then I won't get into this too much because it's a bit technical, but we also have an API tool. And I mention it because it's a really great way to access data across multiple data sets. And so ignoring the code here, the important part is that users can create filters. So filters are things like a bounding box or a parameter that you like or a location specification so that you can pull data from a specific list. And then you can see exactly how many data sets fit your criteria. So the groups that are using this kind of tool are going to be researchers, for example, that are interested in a contaminant across a large region. So we've had researchers interested in nutrients across Canada, for example. So for them, they can use this API, like how we pull data onto our system, they can pull data from our system into their tools as well. And so if you have any questions about that, happy to go into more detail. And yeah, on that note, I went pretty quickly through the tutorial. So if you want anything more in depth, or if you have any specific questions about how to find or access data, just reach out to our team and we can schedule a tutorial with a data specialist. We'd be happy to help you get what you need. Okay, so now that you've learned a little bit about how many organizations are collecting data and sharing data and how all that data needs to be formatted, a question we're still often asked is, what's the point of sharing data openly, or what's the value of all of this open data? And I have a few examples. The first is collaboration. So by bringing people, stories, and data together across all these different sectors, it makes monitors aware of one another, first of all. So in that example where there was 5 groups monitoring the same area, it'd be great if those groups knew that each other exists so that they don't duplicate efforts. It's also a great way to connect monitors with data users and decision makers. And a quote from our 2023 external evaluation is that no one agency can do all the monitoring. So having access to open data allows for more thorough analysis of the status of an area. There's also data preservation. So open data platforms like ours prevent data from getting lost, and DataStream specifically ensures that data is available for generations to come, and we've designed the system accordingly. So data is going to be much safer in a system like DataStream with a minted DOI than, say, in a cupboard somewhere that it might risk getting lost or not found. Transparency and trust. So we find that it's important for regulatory groups to publish and share the data that they collect, and this can often improve trust in communities. Visualization and accessibility. So you just saw some tools that we provide and other systems may provide for data access and visualization. So map tools, graph tools, water quality guides, all of those things make data a little bit more accessible to people rather than just a spreadsheet might be. And maybe they can make a little bit more informed understanding of what they're looking at. And then finally, and probably most exciting, open data can extend that data's reach. And by sharing data openly, data can be used in ways you didn't originally plan for, which is really exciting. So on that note, as more and more people are using data and are using DataStream to uncover insights about the health of their watersheds, we try to connect with those people and we want to learn from data users, whether they're using their own data, whether they're using others' data. So that would be that secondary data I mentioned. And in these secondary use situations, we also try to relay those data use stories back to the stewards so they can learn about the impact of their data and who's using it and what they're learning from it. And so here are just some examples of how we're seeing open data get used. The first example is research and new data products. So researchers are able to use open data to inform their studies. So if you've ever been a researcher, a large part of that work is pulling data sources together, finding out what data exists and what's available. And so a lot of researchers have started to use open data from DataStream in their work to pull several sources into one place. And so here's an example from Nature in 2024. This was a paper from DFO researchers who pulled together pH and calcium data from across many sources. And using these data sets, they were able to create high resolution dissolved calcium and pH data layers. And we were super excited to see that dozens of DataStream data sets ended up being cited in this paper. And particularly, there was a huge portion of community-based monitoring data set groups cited. So that was a really excellent example of how even some of the smaller data sets on DataStream can contribute to a larger research data product, and how pulling all of these small, large, long, short data sets together, you can create this larger product that can be used in hopefully many ways. Modeling tools is another great example of how open data is used. So as we all try to understand our environmental systems, we're seeing more and more modeling tools get developed the last few years. And modeling tools, especially those that use machine learning, need a lot of data, and they need that data in computer readable formats. So since we have that API that I showed you, modelers can connect data from our system to their modeling tools and filter to their needs. And so here's an example of a modeling tool. It's called Poseidon, and it's in development. This project is led by Dr. Nandita Basu at the University of Waterloo. And this tool provides predictions of stream nutrient concentrations and loads, along with landscape nutrient inputs. And to feed their models, they use nutrient data from DataStream across regions and organization types, and they combine that data with other data types to create these predictions. Watershed reporting is another example of data use. It's extremely valuable. That's usually when organizations pull together specific data types and summarize that data at a watershed level to assess health. So I mentioned the Lake Winnipeg Foundation is one of our partners. Their community-based monitoring network is a collaborative long-term phosphorus monitoring program, and it's designed to identify localized phosphorus hotspots so that they can know where action is needed to improve Lake Winnipeg water quality. And so they publish that raw data that the communities collect on DataStream for transparency and reuse, but then they also provide annual hotspot reports showcasing where the highest levels of phosphorus loading are. And those reports go back to the community members that were volunteering. And just this year, they released their amazing Phosphorus Explorer map, which is an interactive hotspot mapping platform, which pulls all their data and all their maps together across all their years of monitoring into one place so that you can explore how your watershed maybe has changed over time. Media is another example. This is a less common use case, but for those that are going to review reporting on an environmental issue, it's important that you have evidence, of course, to back up your story. So in this example, a few years back, a CTV journalist exploring the impacts of road salt pollution on waterways in Canada needed data. They needed a widespread source of salt pollution data across Canada. And after learning about DataStream, they came to us to access the information they needed to help inform their investigation. And then facilitating collaboration alone is a really cool use case of data. As I was talking about the value of open data, it's a great way to facilitate collaboration between data collectors and data users. So this example showcases DFO's community-based monitoring program in the lower mainland of BC. So it's called COSMO. And this program is comprised of over a dozen stewardship organizations, as well as multiple academic groups and municipalities. And they deploy high frequency water quality loggers across the region. And recently, a graduate student from UBC tapped into this data set using our API and created a little web application for community groups to visualize the estimated chloride concentrations based on the high frequency conductivity data. And these estimated chloride concentrations can be compared to freshwater guidelines to help you understand the health of a watershed. So this was a really great full circle example of where communities collect data. That data is then interpreted in useful ways, which can then be relayed back to those communities. And then finally, program design. So open data can be used when it comes to developing or designing monitoring programs. So we don't want to reinvent the wheel. We want to be useful when we're monitoring. So we want to understand where people are monitoring, see where collaboration is possible, and identify gaps that might need to be filled. And so this example highlights another regional partner of ours, which is the Atlantic Water Network. And in 2019, the Atlantic Water Network did a sufficiency analysis where they examined data on Atlantic DataStream to identify watersheds where data was lacking at a local scale. And they were able to identify regions that were rich with monitoring, but they were also able to identify regions that were lacking. And so with these insights, they're able to target their research, their outreach, and programming where it was needed most. And all of these are great examples of this sort of data to policy lifecycle, where you have monitors from a wide variety of places and contexts. They're collecting water data and they're sharing it. Ideally, they can then share that data openly on platforms like ours. That open data then can advance scientific knowledge and support collaboration. And then that knowledge can be translated into action. And action may be to fund or create new monitoring initiatives often. So that way the cycle starts again and more valuable data is collected and shared and can be used. And so as I kind of reach the end of my presentation, I thought we could review some of the key messages or kind of key takeaways that I share today. So if anything that you take away, hopefully it's these things. The first is that there is a lot of water quality monitoring happening across Canada and the Great Lakes. So we saw just how many collection organizations are collecting data. We're seeing that monitoring technologies are getting smarter and so more collection can be done more affordably, which is really great. Hopefully you've learned that community-based monitors are really important. They're connected to their waters and they're best placed to see changes as they happen. And this community-based data can be combined with other data like government monitoring programs to inform decision-making. Data management matters. So just like collection protocols, data management is really important to make sure that data lasts and can be reused. And we need to make sure that it's formatted correctly and contains important metadata so that it can be understood and trusted. And then finally, open data can help protect fresh water. So through all of those use case examples we saw all the ways that open data can be used and leveraged to inform us about the health of our waterways. And ultimately, better data means better decision making. So with that, if anyone on the call here has got any data that's hidden away in a cupboard or that you haven't had a chance to upload yet and you're interested in sharing that water quality data, please do get in touch. We say this all the time, but open data really is a team sport and collaboration is key. So I'd like to thank our regional partners and our collaborators and supporters, specifically in the Great Lakes. I want to thank the Canada Water Agency for their support as we're funded under the Great Lakes Freshwater Ecosystem Initiative grant. And with that, I'll thank you and leave all my contact information here if you have any questions or follow-ups.
Amazing. Thank you so much, Megan. We now have some time for questions and people have been dropping them in, which is great. Before we get into that, Nicole is just going to be dropping a quick survey link. If people can take a few minutes to answer that. It's anonymous, just helps us know how we did today, and also if there are other organizations or speakers that you would like to see featured in a future webinar, that's how we get that information. So our first question is, what has been the biggest challenge to getting the public and stakeholder information about freshwater, water quality, and watershed management?
Sorry, can you say that one more time? You just paused at the worst time, I think.
Oh, sure. What has been the biggest challenge to getting the public and stakeholder information about freshwater, water quality, and watershed management?
Yeah, I think it's just like I mentioned, I think it's just the first step is finding out what's out there and what's available and who's doing what. And I think that's kind of probably, I said the word collaboration about 100 times. I think that's where that's key because then you can find the right people who have the right information. Almost a lot of the onboarding that I do when we find new data sets or new data users, it's through existing contributors or through existing data users that know one another. So we try to be that kind of connecting system to connect all of this together. And that's how we find who's doing what.
Great. And we have a follow-up question to that. How much of the data do you think is limited to public information?
What do you mean by limited to public information?
We'll let that person privately message us and get some
Okay.
clarifications. So we'll go to the next one.
Okay.
What do you think is the biggest gap in data, and what do you see as the solutions to fill those gaps?
Yeah, I mean, I think a lot of people will tell you that where we're seeing at least spatial gaps are areas where government groups aren't able to monitor. And I think that's where the value of community-based monitoring comes in. I think if you're only to look at government collected data, you'll get really great long-term data sets, but in very specific areas where it's quite easy for government agencies to go and collect data. Whereas I think that's where community groups are really well positioned to collect data in places that are harder to get, that only maybe the locals know their way through and they can access the water and get the data that way. So yeah, I think that's at least the spatial gap and a way to fill it.
Our next question is, what types of stakeholders do you see most often involved in water collection and use, and who is missing from the work and those conversations?
Yeah, like I said, I think we see in terms of the data collection, I think we see a lot of different kinds of data. Our role definitely is to try our best to support those community-based monitoring initiatives and Indigenous organizations to make sure that their data is leveraged because often those data sets aren't already on a portal, like say a provincial government data set might be. But I think overall, we kind of see a pretty well-rounded variety of data collection group types. In terms of data users, I think researchers are definitely the ones that I work with the most. I think researchers have a great love of finding data from as many places as they can. So I think that's like the biggest boom right now is we're seeing a lot of those researchers and those modelers come to us to try and find data and use data for their systems.
The next question is about the Lake Partner Program, which I think you mentioned as one of those when you did the Zoom in. So someone's just asking how they can access if there's a Lake Partner Program specific filter to get the test results that they were collecting. So maybe they're not getting it back from the Lake Partner Program, and so they're wondering if they can go into DataStream to get it for what they've collected.
Yeah, you definitely can do that. And I'd be glad to help you if you ever wanted to hop on a call. But at a high level, what you could do is exactly as you said, Monica, on that Explore map, you can find that like partner program. You can then save that DOI link. And then you can zoom into the map that I showed you and select just your water body. So if you know where it is, you can select just those points, just like I selected those 2 sample points there. And then you can actually, there's a button to download just your selected data points. So you could do that. Or you could just look at the graph in the map and explore the data that way. But I'd be more than happy to hop on a quick call to get you the exact data you're looking for.
Okay, the next question is, how is the data always spatial? What do you do if the data doesn't contain coordinates but location descriptions?
Yeah, so that's really tricky. As I mentioned, location coordinates is one of our kind of key pieces of information that's required. So data has to have a coordinate that for it to be uploaded. That said, though, we do have some columns that describe a bound around those locations. So often what we'll do is we'll meet with a steward. They know roughly where they went out in the canoe to get the data, but they didn't write down the coordinates. So what we can do is we can estimate kind of a center point and then put a bound around that point to kind of, give a rougher, more buffered estimate of where they went out. But that's kind of our role as data specialists, is kind of help you look back in as many old forms you have. Maybe you have a map of where you go out, but you don't know what the coordinates are, and we'll do our best to sort of kind of gauge those points with you. But the buffer is the best key option for those kinds of groups, I'd say.
Someone is asking about funding. So they represent a cottage association. They would like to have more regular monitoring, but they have a very limited budget. Is there a way for them to partner with DataStream or maybe some of those other partners you put on the last slide to access funding and equipment to do the monitoring?
Yeah, I definitely probably would have to follow up on this. I don't know if I have the best insights, but generally we don't fund monitoring groups, but we can definitely connect you with partners. And also, a lot of the times, our role when people are trying to find funding is to write letters of support and to help you with that data management step. So when you're looking for funding, you can say, hey, we have this data management step that will be supported by DataStream and in-kind contributions. So that way we can help. And yes, we do have a large, obviously you can see a large list of monitoring groups. A lot of them are higher capacity. So perhaps if you're curious, you could reach out and we could see if we can connect you with anyone that might have better insights on that kind of stuff.
Someone is wondering if you offer resources or the data points in French.
Yeah, that's a good question. We do have most of all of our online resources have a French side, so our datastream.org, you should be able to navigate everything in French. So that includes things like our nutrient guidance, our ions guidance, our metals guidance, and our template also descriptions at a high level should be in French. And we actually have I showed you that list of data specialists. One of our data specialists, Charlotte, she is our specific French data specialist who worked with our Francophone data contributors.
Great.
That's a great question.
Has DataStream ever explored hosting transboundary data, so the US and Canada?
Yeah, we have explored, and we actually do have a little bit of US data. While we are a Canadian charity and we're funded by Canadian organizations, so that's our main priority. But especially like we're talking about the Great Lakes today, you can't really get a full picture of the Great Lakes without looking at both sides of the picture. So we have made some partnerships across the border, and we do have a few data sets coming in on that side. So one that comes to mind is an organization called the Lake Erie Volunteer Science Network. For some who might have heard of that, it's a collaboration of a lot of community-based monitoring groups on the US side of Lake Erie. And they contribute their data to DataStream through an integration so that if you're looking for Lake Erie data, you can pull data from both sides. And so it's always something we're considering, and we're definitely taking it in when we can.
Awesome. The next question is if you're seeing any trends for what groups are monitoring for, things that people are trying to fill in the databases.
Yeah, that's a good question. You probably just even saw it. I think chloride is a big one right now, like road salt monitoring. That's really big. And then what's really cool is that depending on what hub you look at, you're going to see different issues, right? So if you're in Pacific data stream, salmon health is a big concern, or Atlantic data stream. So you're going to look at pollutants that impact salmon. But in Great Lakes data stream, we're really interested. We tend to be very concerned about algal blooms. So we're going to be measuring a lot of nutrients. So I really think it's situational, and each hub kind of has their own concerns. If you're in like Winnipeg data stream, oil sands monitoring is going to be a big issue. So I think it depends on, the region that you're in and the issues that you're trying to sort out.
The second part of the question, I think you have answered it already, but I'll just ask it anyway. Someone is saying if they're looking at starting to do monitoring, are there some that they should, like a starter pack, I guess, of what they could monitor for if they're just starting and they're not sure what they should be looking for?
Yeah, for that, I would probably point you maybe to Water Rangers, as I mentioned. Water Rangers is a really great, affordable way to sort of start monitoring, and it's quite basic parameters that the kind of standard kit has, but those parameters can give you insights into maybe some issues. So, like temperature and conductivity aren't going to tell you everything you need to know, but they might tell you if something's slightly off. And then with that information, you can maybe collaborate or talk to a researcher or look at local issues. And then you can see maybe what you want if you have capacity to monitor further, or maybe like more laboratory style parameters as well. But yeah, Water Rangers is a great place to start, I would say, if you're just starting out, or find a local monitoring program that's already existing and join them if they are accepting volunteers.
Okay, great. Someone's wondering if DataStream, I guess, staff do any in-person training days, like coming out and how to monitor or how to upload the data, or is that just the online calls that you were talking about?
I think if there are opportunities for in person, we're always interested for sure. I think it's just a case by case basis. So if there's a data specialist that's accessible to you and you'd like to invite them to do a presentation, we wouldn't be able to train on things like monitoring. That's not our specialty, but on our templates and on data management, that's definitely something we'd be interested in doing either on Zoom or in person, and we definitely have before. So, yep.
Perfect. I will let people know that there's a couple minutes left if you want to submit any other questions. We're getting through most of them, which is great. So the next one is, how is DataStream helping Indigenous communities?
Yeah, that's a great question. And when we are kind of prioritizing groups to support and to onboard, like I mentioned, community-based groups and Indigenous organizations are definitely top of the list. When it comes to Indigenous organizations, we recognize that data sovereignty is super important. So our goal is to kind of meet groups where they're at and where their interests are. So if you're an Indigenous organization who's collecting data and you don't want to share all of it, or you only want to share some of it, we will match you where you are and help you with what you need. So yeah, we're definitely always willing to engage and work with those communities for sure. And we definitely have some Indigenous data on the platform.
The next question is, has DataStream been brought under the attention of municipalities?
Yeah, that's actually an area that we're hoping to grow a bit in. We don't have as much municipal data as we have, say, like provincial, for example. But definitely there has been a little bit more, at least I've heard noise, and people connecting us with their municipal governments, mostly because the data users want the municipal government data and they want that data on DataStream. So we're ready and willing to work with municipal data holders for sure.
Okay, I think we've gotten through all the questions. So if anyone has one last one, you can put it in the chat. Otherwise, Nicole is going to copy and paste that survey link again. And it's something that I ask after every webinar, but it is very helpful for us in deciding the new topics and also going to our funders and being able to say that people are finding these webinars helpful and we should have more of them. So really appreciate you taking a few minutes to fill that in. But it's looking like we got through all of the questions. So thank you so much, Megan, for your time and sharing your expertise and making it through. I think we got through almost 15 questions. So thank you so much for sharing all your expertise. And thank you everyone for joining us today. And we will keep you posted for the next webinar coming in a few months.
Thank you.